Good afternoon, this is Schweitzer, and this is the second part of this worksheet. So let's take a look at just getting started on this particular page. It's got a lot of stuff here. We got some notes here we might add in. So it says draw the Bohr diagrams for 1 through 20 valence electrons and atoms. Alright, so here the valence electrons for each, now they're kind of correlating here. First column, second column, third, fourth, fifth, through that. So it's going to be valence electrons would be 1. So draw the Bohr diagram for the ions. Okay, let's just do this here quickly. 1, 2, 3, 4, 5, 6, 7, and the last column is 8. Ions, in order to get gain or loss, so to get to a full shell, now this guy could be 2 if you're looking at helium. So helium would be 2. Either way, this is going to lose 1, lose 2, lose 3. This one could gain or lose 4, gain 3, gain 2, gain 1, and then nothing. All attempt to get to our sort of our octet or duet rule. Okay, octet rule. So, okay, valence electrons. Now again here, we're hoping at this point, after this is valence electrons and ions, they all should be full. So I'm not going to put much here. I guess you can if you want, but 8 or 2 for everything. It exposes a full inner shell on everything. A real common charge. Okay, so let's look at this guy here for, let's say, hydrogen. Okay, hydrogen's got 1 proton, and it's got 1 electron, which is empty. So it's got a positive 1 charge, 1 proton, no electrons. This guy here has got 2 protons, and it's got 2 electrons because it didn't gain or lose anything. It's got a full shell, so its charge is 0. Okay, the next one, this guy here has got 1, 2, 3 protons, and it's got 2 energy levels, but it lost that last one, so it's just going to be 1, 2. So 2 positives, 2 negatives, and positive 1. Alright, 4 positives, and we got, in this case, that's it. Alright, plus 2. And then we got 5 positive protons, and still, it's kind of strange, but it still only has 2 electrons. It lost 3 of them. So plus 5 minus 2 is a plus 3. And now we're starting to gain. This is a difference maker here. So metals, in this case, metals gain. Metals, alright, they lose, okay, electrons to form, we call cations. Positives. But nonmetals, big difference, nonmetals okay, they gain electrons to form, we call anions. And we should already know a lot of these terms already. Okay. And so we got 6 positives, but now we're gaining electrons to fill this shell. This one's full already, so we gotta go to our second shell that we're filling. Alright. So these guys are losing electrons to pump back to a previous energy level. These ones are gaining to be similar to the neon electron, neon. So this guy's got 10 protons, all right, and it's got one, all right, and it's got, and there we go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everyone wants to get to this stable point here. So, that being said, we got 6 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to gain 3 electrons, giving it a negative 3 charge. This guy's going to have 7 protons, and it's going to have to gain 3 electrons to get to its, I shouldn't say that. Okay, let's back up here a second. All right, 6 protons. All right, this atom here is boron. Okay, this atom is carbon. This atom is nitrogen. This atom is oxygen. This atom is fluorine. Okay, now carbon's in a teeter-totter point. Okay, so 6 positives. 1, 2, 3, 4, 5, 6. All right, so let's just do it this way. Okay, so typically speaking, it doesn't do anything. It can, and it's hard for it. I'm going to get my eraser here just for a second, so we can see what this looks like better. All right, and I'm just going to, yeah, that's good enough. All right, and let's take this thing and say it does neither. I'm just going to stay with it. It could do it or could not. Bigger atoms at the bottom of the periodic table, like lead in this family, do this, but it's just going to have no charge, or plus or minus 4. I'm not going to write it in here. You can do it if you want. Either add 4 or subtract 4. I'm going to leave mine the way it is, plus or minus 4 if you want. I guess we could put it in here. Actually, I'm going to do neither. Don't worry about it. So nitrogen. Now nitrogen's got 7 valence electrons. Now it's tipping towards this side. 1, 2, okay. And it's going to be the same as this guy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's minus 3. This is plus or minus 4 if you want to go to neon or you want to go to helium. You decide. Alright, oxygen is 8 protons and 1, 2 energy levels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And it's going to be a minus 2 charge. And then the fluorine is going to be 9 protons. Alright. Once again, looks identical to that. All of these look identical to the noble gases because that's the point of stability. And at that point, common charge. Well, this whole family here forms a plus 1 charge. You note that trend continuing here. This will be plus 1, this will be plus 2, and so on and so forth. So plus 2, plus 3, all right, plus or minus 4 when it gets bigger or nothing, minus 3, minus 2, minus 1, and typically no charge on our noble gases. So this is just a little start into how we set up this particular page. Now one important thing you kind of want to get out of this thing here might be, anything else down here? Draw a Bohr diagram for each common ion, focus on protons, electrons, show energy levels. Okay, we did that. So, but one thing you kind of want to make sure you understand, take away from this thing, is that on our periodic table, not a very good one here, we have a couple of representations here. One, these rows represent energy levels. All right. Okay, and then number of valence electrons, 1, 2, 3, 4, 5, 6, 7, 8, and then of course our charge, plus 1, plus 2, plus 3, plus or minus 4, and then minus 3, minus 2, minus 1, and then 0. That's a pretty big takeaway on these things. And the separator, the delineator here is the metals versus the non-metals. These guys are losing to get to the noble gases, and these guys are gaining. These guys form cations, these guys form anions. All right, we'll stop there for that moment. Thank you.